All right, so we're moving on to lesson 7 in the number sets and arithmetic expression unit, and this is the introduction to powers. A power is any expression that represents repeated multiplication of the same factor. A power is comprised of two parts, the base and the exponent. The base is the value being multiplied repeatedly, and the exponent is the number that indicates the number of times the base value is being multiplied by itself. So in this example here, we read 5 to the power of 2. 5 is your base and 2 is your exponent. And that means that we have a base of 5, and it's going to be times by itself, or repeated multiplication, 2 times. So we would go 5 times 5. The base of 5 being multiplied by itself twice. That's what the exponent 2 tells you. Okay? When repeated multiplication of the same factor is expressed using an exponent, we refer to the expression as exponential form. So for example, rewrite each of the following expressions in exponential form. So we want to take that repeated multiplication and we want to write its equivalence with a base and an exponent. So if we take a look at example A, we have 2 times 2 times 2. So 2 is what's being multiplied by itself, so that's your base. You have a base of 2, and it's being multiplied by itself 3 times. 1, 2, 3. So that is your exponent, 3. So we went from expanded form to exponential form. If we take a look at B, it's 3 times 3, so 3 is your base, and it's being multiplied by itself twice. There's 1, 2. If we take a look at C, so this is 1/2 times 1/2 times 1/2 times 1/2. So our base is 1/2, and we can write that with brackets, just like they have here. And it's multiplied by itself 1, 2, 3, 4 times. So that can be written as 1/2 to the power of 4. And D has the value of 5/10, 0.5 or a half there. And it's only being multiplied by itself once. So if it wants it in exponential form, that would be 5/10 to the power of 1. We don't normally write the 1 because to the power of 1 is the same as just saying 5/10. Okay? So you normally don't see 1 as an exponent, but that's what it means. Okay, and so we went there from expanded form, this repeated multiplication, to exponential form. We can also go from exponential form back to expanded form. So when repeated multiplication of the same factor is expressed without the use of an exponent, we refer to this expression as expanded form. So if we take a look here, so you have 5 to the power of 4. So rewrite the following expressions in expanded form. So we want to see repeated multiplication here. So you have a base of 5, and you're going to multiply it by itself 4 times. So 5 times 5 times 5 times 5. 1, 2, 3, 4. So that's your exponent of 4 and your base of 5. Same thing for B. We have the base of 3/10, 0.3 here, and it wants us to multiply it by itself twice. So you could write it as 3/10 times 3/10. Also write it with the multiplication sign. 2 brackets next to each other also just means multiplication. Okay? So taking a look at the first 2 practice problems in this booklet, what is a power? And with respect to a power, what is the difference between the base and the exponent? I just read that to you. It's all up here. I'll highlight it. So a power is any expression that represents repeated multiplication of the same factor. Okay, so that's what I would write in your booklet. And then you can come up with the difference between a base and an exponent. Okay, so I'm not going to leave you time in this video. That'll be something you come back to at the end to make sure that you write those definitions down. Or you can pause the video right now and get question 1 and 2 completed. Okay, but let's go on with question, so this should be question 3, my mistake here. So let's go on with the next question. Write the following in expanded form. Okay, so just like we were doing previously, What I would encourage you to do actually right now is maybe pause the video, complete questions 1, 2, and the second 2 here, and then unpause the video and see and check your solutions for A, B, and C, and D. All right, so hopefully you've had a chance to try these questions on your own, and let's just take them up. So for question 2, you have a base of 3, and it's being multiplied by itself twice. So that's 3 times 3. For question B, you have a base of 2, and it's being multiplied by itself 3 times. 1, 2, 3. So 2 times 2 times 2. For expanded form for C, it's just 10. It's a repeated multiplication of the base 10 times itself once, so just 10. For D, you have a base of 7, and you're going to multiply it by itself 4 times. 7 times 7 times 7 times 7. Okay, so take a moment if you need to pause the video to try answering question 3. Write the following in exponential form. All right, so 5 times 5. So right away you get your base from looking at the repeated multiplication. That is 5, and it's multiplied by itself twice, so 5 squared. You have a base here of 8. I can see that because that's what's being multiplied. And 1, 2, 3, 4 is 8 to the power of 4. For question C, you have a base of 4, and it's being multiplied by itself 3 times. All right, take a moment to see if you can come up with a simplified notation for A and B for question 4. So you might use exponential form. See what you can come up with. Okay, so for question A, it's that repeated multiplication, so we're going to use exponential form here. So this is 5 to the power of 3. That's what we've been doing in this lesson, but B is something we kind of looked at last lesson or 2 lessons ago, so a little bit trickier. Okay, but you have 5, and it's not being multiplied, it's being added by itself 3 times. So to write this with a simplified notation, we have 5, and it's going to be multiplied by 3. Okay, so the difference between multiplication, repeated multiplication gets you an exponent. 5 plus 5 plus 5 is just like saying 5 times 3. All right, 5 times, so added, so 3, 5 added to itself 3 times would be 5 times 3. All right, for question 5, this is where it wants you to evaluate. So you're not putting it into repeated multiplication, you're just going to evaluate that. Now, to find the product of that repeated multiplication. So you can complete, 2 times 2, or in this case here, 2 times 2 times 2 times 2 times 2 in your calculator, or you can use the exponent button on your calculator. So I've got here, so on Google, I've just opened up a scientific calculator, and what we have is this button here, x to the y, and that is the exponent button on this calculator. You might have a different one. So if I take a look at images, and we take a look at your calculator here, okay, so normally I have you not using a calculator, but if I do want you to become familiar with that calculator or that exponent button on your calculator. So if you have one, you're welcome to pull it out and use it. Otherwise, we'll review the exponent button tomorrow. But I'm just going to open up so on this, if you had this calculator, this is your exponent button right here. It's like x to a little square. If you had this calculator, it's this little triangle or arrow up. Okay, that would be your exponent button. It's the same button here, that arrow up. Again, that arrow up. Okay, see if I can find a different example. So similar to the first one, it's x to a square. I think this one is y to the x here. Okay, so those are the buttons you're looking for on your calculator. So if I go back to here, I'll just write them. The one that's most commonly used looks like this. Okay, or you might have x to a square, or you might have y to the x. So those are the exponent buttons you're looking for on your calculator, and you can practice with them today, and I will go over them with you tomorrow. But for example, if we were doing I here, instead of saying in my calculator 10 times 10 times 10, that repeated multiplication, you would press 10, then you would press this the exponent button on your calculator, and then you would press 3 and then equals, and you should get the answer of 1,000. If we try 2 to the power of 4, so if you press your base first, 2, you press your exponent button, whatever it is on your calculator, 4, and that, so 2 to the power of 4 would be 16. Okay, so if you don't have your calculator in front of you, don't worry, we'll practice this. You can just do the repeated multiplication and do the mental math in your head. If you do have the calculator in front of you, try those 2 examples and see if you can get those answers. All right. This is all posted on NCVLE as well, so if after this video you need to go get your calculator and then you want to practice using that exponent button or that power button, you're welcome to do so. But I will go through these with you. So pause the video right now, take a few minutes to complete A to I, and then I'll give you the solutions. All right, so hopefully you had a chance to try those questions. So 2 to the power of 1 is just 2 times itself once, so that's 2. And if you were to try that on your calculator, putting 2 to the exponent 1, you're going to get 2 on your calculator. 2 to the power of 2, 2 times 2, which is 4. 2 times to the power of 3, 2 times 2 times 2 is 8. 2 to the power of 4 we've done to get 16. 2 to the power of 5 is 35. What you'll also notice is you're taking these answers and you're just timesing it by 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 35, because our exponents are going up by 1 each time. 2 to the power of 0 is difficult if you don't have a calculator and we haven't talked about this yet. But if you were to put in 2 and then your exponent button 0, you're going to get a value of 1. And that being said, we'll talk about that more tomorrow, but any exponent or any base to the power of 0, doesn't matter what it is going to get you a value of 1. So if you have like 32 to the exponent 0, it is 1. If you have 105 to the exponent 0, you're going to get a value of 1. All right, and in tomorrow's lesson, we'll discuss why that's so. All right, 3 to the power of 2 is 9, and 5 to the power of 2 is 25. All right, question 6 wants you to graph both tables on the same axes and then answer the questions below. So we have relationship A and relationship B. Relationship A, they haven't evaluated these answers for you yet, but you have them up here. So I'm just going to write them beside, like 2 to the exponent 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4, which I'm just getting our answers that we already figured out up here. 2 to the power of 3 is 8, and 2 to the power of 4 is 16. Okay, so if we were to graph these points on our graph, so they give you the axes here. This is your x value, and this is your y. So my x's I'm looking for down here, and then my y values I'm going to use my vertical axes. So my first point is 0, 1. All right, so my x is 0 and my y is 1. So if this is 5, that means this would be 1, 2, 3, 4, 5. So I have the first point right here. And then I have the value, the point where my x is 1, my y is 2. So when x is 1, so this is 1, 2, 3, 4, 5. So when x is 1, y is 2. So I'm going to go up 1. When x is 2, y is 4. So here's x2, y is going to be 4. When x is 3, y is 8. So way up here. And when x is 4, y is 16. So it's starting to grow really quickly. So we'll just kind of connect those with a curve there. So that's relationship A. So I'll label it A here. I'll use a different color for B. Okay, so B, we're going to do the same idea. We're going to take the points from this table of values and plot them on our x, y. We don't need to evaluate because they just give us the values here. So our first point is going to be 0, 0. Our second point, when x is 1, y is 2. So x is here, y, so it's going to be right there. When x is 2, y is 4. So right there. When x is 3, y is 6. So right here. And when x is 4, y is 8. So right here. And what that has actually created is a straight line. So I don't need to draw that with a curve. I can just go from 0, 0. And if you take a ruler, you'll notice that you can put a ruler mark through all of those points. Just keeps going. So this is relationship B. So we graphed both of these table of values on the same axes. Let's kind of show you the difference here. So this one kind of starts the same, but then it curves and it grows quickly. A, B goes up by the same amount each time. So then it asks you which relationship is linear. Now linear is another word for, linear is another word for line. Okay, and we'll focus more about linear and nonlinear in another unit, but just to introduce you to the idea of linear, that means a straight line. So which relationship is linear? A has a curve and B is that straight line. Which relationship is nonlinear, which means a curve, and that's going to be A. And then which relationship would model a zombie plague and explain your reasoning? Okay, so one relationship would be the better answer or the more correct answer for a zombie plague because if you think about it, as zombies attack more zombies, like if you have one zombie, then after a day you might have 2 zombies. But then both of those 2 zombies are going out, so after a day after that you might have 4. And then after a day after that it might be 8. And it's going to start to grow rapidly as those numbers of zombies increase rapidly. Okay? So a little bit of a Halloween question here for you. But A would be the better option for you. Or would be a better model to represent a zombie plague. Because as the number of zombies increase, it's going to start to increase more rapidly. Okay, so I would say A, and I'll let you come up with a reasoning on your own there. Okay, so take a few minutes to complete question C. A is the better model, but come up with the reasoning on your own, and then there's some homework questions for you. Okay, if you have any questions, please reach out, and we will take this up tomorrow.